Okay, good morning class. So at this point we're looking at equations and inequalities. This lesson was done with the grade 10s, but during this time we were experiencing load shedding at the time. So today we're looking at quadratic equations in one unknown. Okay, this is exercise 4.5, and that is on page. Let me get the reference. Example on page 79. Okay, so we're looking at quadratic equations in one unknown. We are told that the algebraic equation, the polynomial equation, with the standard form of ax squared plus bx plus c equals 0. When we were factorizing trinomials, we're doing it without that 0 in expression form, where a, b, and c are element of integers, so that is from 0, 1, 2, 3 all the way to infinity, and negative 1, negative 2, negative 3 all the way to negative infinity. To solve these equations, we use the fact that if the product of the two or more factors is 0, at least one of the factors must be 0. Okay. So as explained, if I have a times b equals 0. So if a was, for argument's sake, 5, then what must b be for the sentence to be true? With the equation to be true, b has to be 0. If a was minus 2x squared, what must b be for it to be 0? 0. So whichever value you choose for a, b has to be equal to 0 for the statement to be true. So if I go the other way around, if I go vice versa, okay, but now say, what must a be if b is 6 for us to get 0 out? A has to be 0. What if b was negative 2 over x? Okay. Now some restrictions will come into place there, so just rather keep it simple. What if it's 2x over 3? What must a be for that to give you 0? It has to be 0. So it's either a is equal to 0 or b is equal to 0. And this is what we call, that I'll refer to later on, as the 0 factor rule. So one of the factors must be 0 for that story to be true, okay, or the equation to be true. So here we say, so if a times b is 0, then a is equal to 0 or b is equal to 0. Then we are told if a is equal to 0 or b is equal to 0, then a times b is 0. If a over b is equal to 0, then a is equal to 0, b is equal to 0 is not allowed, because otherwise the sum will be undefined. That is why when I drew that fraction on that side, I think it was 2 over x, I removed it, because there's an extra clause there, is that the denominator should never be equal to 0. Now I'm looking at example 1, and example 1 is on page 79. Example 1 on page 79. So as we can see here in this example, our terms are already factorized. The trinomial is factorized already. So what we do is, we know that x plus 1 is equal to 0, or this factor, one of the two must be equal to 0 for that sentence to be true. Okay. So now it just becomes a matter of solving the linear equation. So x equal to negative 1 or x equal to 2. And it can be tested. Well, let's substitute negative 1 into this equation. So negative 1 plus 1 times negative 1 minus 2. So that is 0 times negative 3. 0 times negative 3 is 0, which makes it work. Okay, which is correct. Or we had gone with 2. So 2 plus 1 times 2 minus 2. So it's 3 times 0, which is again 0, which is the same. Okay. So I'm not going to do that for every sum, but I'm just showing you that That's the statement, that's the values for x is actually true according to our calculation. We will this now example, in example 2, I forgot to give you the steps in which you're going to have to solve this. So the first step is always to get it in standard form of ax squared plus bx plus c is equal to 0. That's the first step we need to do. The second step is we'll factorize if needed. Factorize if needed. And then firstly set each factor equal to 0. Okay, and then solve. Then you'll solve the equation from here. Sorry about that. Then solve. Okay. So those are the steps we will follow once we solve this quadratic equation. So let's look at the next one. This is example 2 on page 79. Example 2 on page 79. And also, this exercise of 4.5 is actually on 81. Page 80. Okay. Normally the students would have corrected me here, but as you can see here, they're not in the class. So the question says solve for x. We've got x squared equals 2x plus 8. So first we must get it in standard form of ax squared plus bx plus c is equal to 0. So we're going to take 2x and the 8 over. So it's x squared minus 2x minus 8 is equal to 0. Now we're going to factorize the trinomial. Okay, now there's many ways of factorizing this trinomial. So I just find the easier of the ways. So we on the side of the barrier write the factors of the coefficient of x squared, and on the right hand side we write the factors of 8, which is your constant. At this point I don't worry about the sign, so 1 times 8 is 8 and 2 times 4 is 8. Okay. So what do? We add or subtract our factors? Of course we're going to subtract it. So 1 times 8 is 8, 1 times 1 is 1, 8 minus 1 is 7. We're looking for 2. 1 times 4 is 4, 1 times 2 is 2. 4 minus 2 is 2. So it's 1 and a 2 in a bracket, 1 and a 4. As you can see, it's x squared, so an x and an x. What about our signs? Opposite signs. Alright, so 1 must be plus and 1 must be minus, 1 must be minus, 1 must be plus. So the bigger product takes the sign of the middle term, which in this case is again negative. So that's going to give us 2x, and of course that is 4x. So 4 is bigger. So the 4 gets the negative, while that gets the positive. And if you're making this mistake on where do you put the negative and positive, what I do suggest you do is you multiply it out afterwards on the side of your page to confirm you're on the right track. Right, so what do we do after this? We set each factor equal to 0, so x plus 2 is equal to 0. Or, if we're applying in the 0 factor rule, x minus 4 is equal to 0. They get over the equal sign, so x is negative 2, or x is 4. Okay. Let's look at the third example. Again, you must keep this in mind, okay? Those are the steps we are going to follow in pursuit of calculating, solving the quadratic equation. This is example 3, and example 3 is also on page 79. Okay. So again, the question says solve for x. So to get it in standard form, I must get rid of the brackets first. Okay. We multiply that out, it's going to give you 2x squared. I know some of you are going to think, why don't we say 2x minus 1 is equal to negative 2, and x plus 2 is equal to negative 2. You can't do that. That will only work if it's equal to 0. So we've got 2x squared, 2x times 2 is 4x. That's going to give you negative x minus 2 plus 2 is equal to 0. I'm bringing the 2 over the equal sign as well. So it's 2x squared plus 3x. That cancels. So that's equal to 0. Again, it's quadratic, so what do? We factorize now. As you can see, x is a common factor. So I'm left with 2x plus 3 equals 0. Do not divide by 0. You'll lose a solution. Okay, then it says set each factor equal to 0. So x is equal to 0 and 2x plus 3 is equal to 0. Okay, so x is equal to negative 3 over 2. If you take it over 2, x is negative 3 divided by 2. So x is equal to negative 3 over 2. Okay, let's go to the next question. This is now on the next page. Yes. Now exercise 4 is on page 18. Okay, so exercise 4 on page 18. We are asked to solve for x. So as you can see, we've got a fraction, so we're going to use, we're going to get rid of the denominator. So we're going to find what we call an LCM or LCD, lowest common multiple or lowest common denominator. So as you can see, LCM is of x, and your restriction, the value for x, for which x can never be equal to, which when the denominator is equal to 0, x is then never equal to 0 then. So naturally that's over 1. So the first denominator 1 must be multiplied by x to get the LCM of x. So we must multiply the numerator as well. So it's x into x. Minus 7, that must be multiplied by x as well. So we multiply numerator by x as well to get equivalent fractions. That's equal to this, we multiply by 1. So it's going to be 30 times 4. Which now gives me x squared minus 7x is equal to 30. Bring that over the equal sign, becomes minus 30 is equal to 0. Again, your product line, I know most of you can see it at this point, it's going to be 3 and 10. So x times 10 is going to be 10, and minus 3 is going to give you 7. So what about the signs in the bracket? 1 plus 1 minus. So the bigger one is going to be, the bigger product is going to be negative. And of course that is negative, well that is positive. Okay. What do we do thereafter? We set each factor equal to 0. So x plus 3 is equal to 0, or x minus 10 is equal to 0. So x is equal to negative 3, or x is equal to 10. Okay? Alright, so now, why we got example 40, so that's example 4. That's example 5. Okay. So here we are told that the perimeter of a rectangular room is 18 meters. Let the width of the room be x. Okay, so we don't need this room actually. This is a picture of it. Put this up. So we are told that the perimeter of the room is 80 meters. Okay, 18 meters, not 80. Okay, perimeter is 18 and the breadth is x. So if we look at the room, the perimeter is going to be 2 length plus 2 breadth. So we're letting the breadth be x. Okay, and the length is of course r. So the first question says write the length of the room in terms of x. Okay, so there are two formulas given here. Area is equal to length times breadth, but we weren't given the area of the room. However, we are given the length, the breadth of the room and the perimeter. So as you can see, for that equation I have one unknown, which is L. So of course I need to start today by saying perimeter is equal to 2 length plus 2 breadth. Or another way of writing that formula is perimeter is equal to 2 into L plus B. This is another way of writing it. So your perimeter is of course 18 is equal to 2 length plus 2x. Your breadth was given as x units there. Okay, so they want you to make the length the subject of the formula. So we take that over, becomes 18 minus 2x is equal to 2L. I divide by 2 both sides, that cancels. So L is equal to 18 divided by 2 is 9 minus x. Okay, that's your length in terms of x. Otherwise, if I had gone the other way, I would have got, and I took L that way and 18 the other way, I would have gotten negative x plus 9, which is equivalent to that. Okay. In B we are told if the length of the room is increased by 3. Okay, so remember what is the length currently? So the length currently is 9 minus x. Okay. If the length of the room is increased by 3, so we have got a new scenario here. Okay. So I'm just going to draw again. So what I do is I just draw so that it can make sense. Okay, so the length is increased by 3. It's going to be 9 minus x plus 3, which is 12 minus x. Okay. And then, and the width is increased by 1. The width is then increased by 1, which the breadth to us increased by 1, so it becomes x plus 1. Then the area of the floor space will be 36 meters square. If the length of the room is increased by 3 and the width by 1, then the area of the floor space will be 36 meters square. So what's the question? It says calculate the dimensions. I'm missing the second part. It says calculate the dimensions of the room. So what are the dimensions? The dimensions are the lengths, okay, of the room. So we are told that the area is going to be 36 meters square. So the area of this new piece is going to be 36 meters square. Okay. So the dimensions, in other words, I need to solve for x. But remember that formula that says area is equal to length times breadth. Okay. Area is equal to length times breadth. So I go with that formula there, area is equal to length times breadth. Why? Because the A is given and the L and B in terms of x is given as well. Okay. So it's going to be 36 is equal to length, which is 12 minus x, times your breadth, which is x plus 1. Get rid of the brackets. It's going to be 36 is equal to 12x plus 12 minus x squared minus x. When you bring it to one side, it becomes x squared plus 11x. You bring it over, it becomes minus 11x. Okay. So it's going to be 36 minus 12, which is 24. Okay. So it's x squared minus 11x plus 24. So what does that now become again to us? That is again a trinomial. Okay. A trinomial to us. So let's factorize a trinomial. Again, you can take it to the product line. But at least I can see the factors going to be x and x, 3 and 8. The signs are going to be the same, so both is going to be minus in this case. So x minus 3 is equal to 0, or x minus 8 is equal to 0. So x is equal to 3, or x is equal to 8. So if I just take it back to the diagram, so if x is 3, so the question says calculate the original dimensions. So the original dimensions, of course, is going to be this here. Okay, so let's pull this down here quickly. So the original dimensions is simply going to be your length, your breadth is going to be 3, and your length is going to be 9 minus 3, okay, which is 6 meters. And 6 times 3 is 18, of course. Okay. If we look at the other one, if x is 8, then your breadth is going to be 8, and your length is going to be 9 minus 8, which is 1. Okay. Now remember that the length is always the longer side to us. Not so. So if we look at this here, I would say this would be the better representation of what's happening. Because if we're looking at the reality, we never have a room that is 1 meter. 1 meter. Otherwise, the passage. Okay. Even though I don't even think the passage is 1 meter. This passage is also a bit broader than that. Okay, so in terms of feasibility, I would go with, or in terms of the real life situation, I think your breadth being 3 and your length being 6 would be the best representation of what's happening. Okay, so that you should be able to do exercise 4.5.